Hello everyone, myself Shashti Srivastav and my roll number is 39. Today we are going to discuss about Galois field. So first of all we must know what is a Galois field. A field F which contains p to the power n elements where p is any prime number and n is any positive integer is called a Galois field. It is denoted by gf p to the power n. Now let us take an example, that is gf2, which will contain two elements, that is 0 and 1 is a field, and gf3 which will contain three elements 0, 1, 2 is also a field. For any finite field, that is a Galois field, number of elements must be prime or prime power. Now taking an example of field containing 6 elements or 10 elements is not a Galois field. Why? Because 6 and 10 are not prime numbers. Now talking about the order of a Galois field, the number of elements in a finite field is called order of the finite field. A finite field is said to have order q if and only if q equals to p to the power n, where p is any prime number and n is any positive integer. Now let us discuss some important points regarding a Galois field. The characteristic of a finite field is necessarily a prime number, that is necessarily a non-zero number. If K is a Galois field having p to the power n elements and L is a subfield of K, then there exists an integer m such that order of L is p to the power n and m is always less than equal to n and 1 is less than equal to m is less than equal to n, where m divides n and order of K over L equals to n upon m. If F is any finite field with q elements and suppose that F belongs to K, then K is also finite field, then K has q to the power n elements, that is order of K over F equals to n upon 1, that is n. If a finite field has q equals to p to the power m elements, then every element A belonging to F satisfies the relation a to the power q equals to a, that is a to the power p to the power m equals a. Any two finite fields having same number of elements are isomorphic, that is, if K and E are two Galois fields having same number of elements, then K is isomorphic to E. Every finite field of characteristic P has an automorphism from A to the power P. The multiplicative group of Galois field is cyclic. If F is a Galois field, then generator of multiplicative group is called the primitive element. Every Galois field contains at least one primitive element. If F is any finite field and alpha does not equal to 0 and beta does not equal to 0 are two elements of F, then we can find two elements A and B in F such that 1 plus alpha A square plus beta B square equals to 0. Thank you.